Yeah, 15. It has to be 15, less than 15, because that's the requirement. Okay, we're in. Okay, thank you so much.
No problem.
Today's class is going to be about hypothesis testing. And hypothesis testing is really nothing but testing hypotheses. That's it. Hypothesis about what? About a population parameter, either mu or p. And we are going to base our testing on a sample. And from the sample, we're going to get statistics, x bar and p bar. And based on these statistics, we are going to make inferences about the population parameter, and that is about the hypothesis that we are going to deal with. So the hypothesis is about the value of the parameters, and we are going to conclude what are these values based on our sample. That's it. Now, in hypothesis testing, we have two hypotheses. What is called H0 and is the null hypothesis, and H sub A, that is the alternative hypothesis. This hypothesis has to be opposite to each other. So if my null hypothesis deals with equal, the alternative hypothesis has to deal with non-equal. If the null hypothesis is greater or equal, then the alternative has to be less. And if it's less or equal, the null hypothesis, then the alternative hypothesis has to say greater than. Now, that's it. And for hypothesis testing, we are testing the null hypothesis. We test the null hypothesis, although what we want to prove is in the alternative hypothesis. Okay? So we test the null hypothesis, but what we really want to prove is in the alternative hypothesis. Okay. Now, in hypothesis testing, we either reject or fail to reject. What we are testing, that is my null hypothesis. Now, and this is important. In statistics, we reject the null hypothesis, or we do not reject the null hypothesis. We don't say we accept the null hypothesis. We just fail to reject. And when we say fail to reject, it means that there is no statistical evidence that's saying that we accept the null hypothesis. So, anyways, now in hypothesis testing, since we are dealing with a sample and we are assuming something about the population, we can make mistakes. What are those mistakes? Let me do exactly as your book says. This is your conclusion. And this is the reality, the real life. Okay? In my conclusion, I even reject the null hypothesis or fail to reject the null hypothesis, right? That is my two possible conclusions I can get from hypothesis testing. But in reality, what's happening? It may be that in reality, the null hypothesis is true and or false, the null hypothesis. So, if we fail to reject a true null hypothesis, we are doing a pretty good job, right? We're good. If we reject a false Null hypothesis, we're doing a pretty good job in our conclusion, right? But what happens if we reject a true null hypothesis? Then we have what is called the type 1 error. This is an error that we make, and this error size is equal to alpha. And we will cover a little bit about alpha. And if we fail to reject a false null hypothesis, we are having this type 2 error. And this error is equal to beta. Okay. What the researchers have control over is alpha, and this alpha is exactly the same alpha as the one that we covered in confidence interval. This is the same alpha. What we don't have control over is beta. However, the relationship between alpha and beta is opposite. If I increase alpha, I decrease beta, and vice versa. And another way to decrease beta is by increasing the sample size or making sure that the variance among the populations are equal. But that's not the case. What is important is that these are the errors that we may have when we do hypothesis testing. And the researcher has control over this alpha, and this alpha is nothing but the complement of the confidence level. Anyways, now, which error is the worst error here? Is it alpha or is it beta? Is it worse to reject a true null hypothesis, or is it worse to fail to reject a false null hypothesis? And the answer to this is like in any question, it really depends. Depends on what? On what we are testing. For example, if we fail to reject a lot of vaccines from our kids, okay, this error is beta, and this is a catastrophic error in this case, right? So beta is the worst case in this scenario. However, let's say that if we reject the innocence of a person that is in trial, and so we declare him guilty, so we reject his innocence, then we are committing type 1 error, and this is catastrophic because of the situation. So these errors really depends on the situation. Which one is the worst really depends on the situation. Okay. What else? Okay. And the most important part in hypothesis testing is the formulation of the hypothesis. I already told you that in hypothesis testing, what we are testing is the null hypothesis. But what we really want to prove is the alternative hypothesis. Now, your book talks a little bit about how to formulate hypotheses, and it says that, for example, if it's a claim that someone is making, then you put the claim in the null hypothesis, because what you really need to prove is the opposite of what this person is saying. For example, if I say that my light bulbs last at least 3,000 hours, or more than 3,000 hours, or whatever it is the claim that I'm making, what I put in my null hypothesis is the claim, because what I really need to prove is the opposite of what this person is saying. So if I have a hospital and I say, my emergency room assists our patient in less than 15 minutes. So what I want to prove is the opposite, is if it's more than 15 minutes. Okay? In that case, my null hypothesis is that the mu is less or equal than 15, and the alternative is more than 15 minutes. That's how you formulate this kind of hypothesis. If it's a claim, is in the null hypothesis, because what you really want to prove is the alternative hypothesis. Now, an important thing about hypothesis testing is that the null hypothesis has always need to have an equal sign. Is equal, or greater or equal, or less than equal. Always the equal sign goes in the null hypothesis, and in the alternative hypothesis is the not equal, less, or greater in each one of the situations. And these are the only three situations that you can have in hypothesis testing. Okay, so if it's a claim, goes in the null hypothesis, because what you really need to prove is the opposite of the claim. If this is a research question, you put it in the alternative hypothesis. If I said that these videos would guarantee my students at least an 80 in the test, I am saying, and since this is a research question, because I'm doing something to prove the improvements of this class, so in this case I'm going to say the null in the alternative hypothesis is that mu is greater than 80 versus that is less or equal than 80. Okay? So this is how you set up your hypothesis. It's the first step, and this is the most important step, because based on the hypothesis, you are going to conclude either to reject or fail to reject your hypothesis. Okay, that's it. I mean, there is nothing more than that. In this chapter, in chapter 9, we have hypothesis about what? Two parameters, the population mean or the population proportion. Okay? In the population mean, we have two alternatives. Either we know the standard deviation of the population, or we do not know the standard deviation of the population. In P, we don't have this situation, so don't worry about that. Now, if we have the situation where we have hypothesis testing about the population mean, when sigma is known, we are going to use the standard normal distribution. In this case, if the standard deviation of the population is not known, we are going to use the t distribution, exactly like we did in hypothesis in confidence interval. And for P, we are going to use the standard normal distribution. Basically, this is what we are going to cover in this chapter. Now, just to conclude and very quickly, in hypothesis testing, you may have only three types of alternatives. Either the two-tail test, the lower tail test, or the upper tail test. Who's going to say which type of test? The hypotheses themselves. If I have that the mu is equal to mu 0 versus not equal, then it's a two-tail test. If I have greater or equal than mu 0 and less than mu 0, it's a lower tail test, and exactly the same thing is less or equal than mu 0 and greater than mu 0. We have an upper tail test. An important part of alpha is what? Alpha is this is the confidence level, this is the confidence level, so this is alpha, this is alpha, this is alpha divided by 2, and this is alpha divided by 2. And these over here, these values are the critical values. This value over here, it really depends on if it's a standard distribution or if it's a t distribution, you're going to get this critical value, and the critical value is nothing but the value that divides this is the fail to reject zone, and this is the rejection zone. These are the rejection zones, Okay, this is the rejection zone. So this is the rejection zone, this is the rejection zone, and these over here are the rejection zones. And it really depends on the test that we are going to make about what, based on what, on the sample statistics. Okay, that's it. That's the introductory part of chapter 9.